Hello, respected teacher. A very good morning. I am Yaqub Abdul Rahim Muhammad, studying in civil second year. Today, I am here to present my presentation, and my topic is about new innovations in civil engineering. First of all, what do we mean innovation? The process of translating an idea or invention into a good or service that creates value for which customers will pay. With the introduction of smart roads and more energy efficient housing, there is a need for construction to get smarter and more efficient too. With more innovative tools and techniques appearing at the same time, here are a few industry changing examples of the new technology used in civil engineering today. Self-healing concrete. Cement is one of the most widely used materials in construction, but also one of the largest contributors to harmful carbon emissions, said to be responsible for around 7% of annual global emissions. Cracking is the major problem in construction, usually caused by the exposure to water and chemicals. Researchers at Bath University are looking to develop a self-healing concrete using a mix containing bacteria within microcapsules, which will aid building innovation by germinating when water enters a crack in the concrete to produce limestone. Plugging the crack before the water and oxygen has a chance to corrode the steel reinforcement. Thermal bridging. Efficient insulation material is becoming increasingly important throughout the construction industry. Heat transmission through wall tends to be passed directly through the building envelope, be it masonry, block, or stud frame. To be internal fascia such as drywall, this process is known as thermal bridging. Aerogel, a technology developed by NASA for cryogenic insulation, is considered one of the most effective thermal insulation materials. This can be used to insulate studs, which can reportedly increase overall R value and industry measuring thermal resistance by more than 40%. Photovoltaic glaze. One of the most exciting new technology used in civil engineering is building integrated photovoltaic glazing (BIPV), which can help buildings generate their own electricity by turning the whole building envelope into solar panel. Companies such as Polysolar provide transparent photovoltaic glass as structural building material forming windows, facades, and roofs. Polysolar's technology is efficient at producing energy even at not facing vertical walls. Kinetic footfall. One of the latest civil engineering technologies under development is kinetic energy. Pavegen provides a technology that enables flooring to harness the energy of footsteps. It can be used indoors and outdoors in high traffic areas and generates electricity from pedestrians' footfall using an electromagnetic induction process and flywheel energy storage. Cloud collaboration. Another new technology used in civil engineering is a cloud collaboration tool called Baystone. Baystone is a system allowing that remote sharing of data on a construction site in real time. It is predominantly a review tool for civil engineers and architects which digitizes the drawing review process on construction projects and allow for better collaboration. The cloud-based collaboration tool is focused on the installation of everything from steel beams to light fittings. Asset mapping. Not all of the latest civil engineering developments are new construction materials or flashy technological tools. Asset mapping focuses on the operational equipment including heating and air conditioning, lighting, and security systems. The process includes collecting data from serial numbers, firmwares, engineering notes of when it was installed and by whom, and combines all the data in one place. This system can show engineers in real time where the equipment needs to be installed on the map, and once the asset is connected to the real time system using the Internet of Things, these can be monitored via the web, app, and other remote devices and systems. It helps customers build databases of asset performance which can assist in proactive building maintenance. It also reduces building procurement and insurance cost. Plastic roads. As a response to massive local waste and plastic pollution within the country, India's government began experimenting with plastic roads during the early 2000s, with waste plastic being used as a construction material. An early report by India's Central Pollution Control Board discovered that even after 4 years of use, the board cited that no potholes, rutting, raveling, or edge flaws were discovered during the evaluation. This level of performance attracted the interest of local governments. As of 2015, an Indian city with a population of around less than 5 lakh is required to construct their roads using waste plastic as a core material. In efforts to promote greater pollution control and environment sustainability for Indian communities. Although the concept of using waste plastic in roads is still in its very early stages, with very few plastic roads currently existing in the Western world, civil engineering researchers in countries like United Kingdoms and United States are working to design new technologies to support this safe construction. Green roofing systems. The Environmental Protection Agency defines a green roof as a vegetative layer grown on a rooftop. Today, green roof systems have become popular all over the world, not only for the beauty but also for the benefits they provide towards the environmental sustainability. Germany is currently leading the world in green roof technologies, and they have implemented green roofing systems on approximately 10% of German homes since the technology emerged in the early 1970s. Civil engineers are responsible for ensuring that the green roof's supportive infrastructure, for instance, a comprehensive watering system, is engineered to consistently deliver an appropriate amount of resource, and the roof itself must be designed to effectively provide working improvements to environmental sustainability. However, civil engineers still face some obstacles when planning the installation and maintenance of green roof systems, like high cost and harsh climates. But innovations in modern engineering techniques for green roofing systems have allowed the industry to consistently offer the environmental benefits to urban communities. The vegetation on the roof acts as a thermal insulation, storing excess heat and decreasing peak temperatures within the building. This means less energy must be consumed to heat the building, resulting in decreased energy cost and lower pollutant emissions. Predictive software. The structural integrity of any building is only as good as its individual parts. The way those parts fits together along with the choice of materials and its specific site all contribute to how the building will perform under normal or extreme conditions. Civil engineers need to integrate a vast number of pieces into building designs while complying with increasingly demanding safety and government regulations. Predictive software can also help us ensure even the most innovative structure in civil engineering are safe and efficient by simulating how they will behave. 3D modeling. Planning and building innovation has been driven by the growth of smart cities. CyberCity 3D is a geospatial modeling innovator specializing in the production of smart 3D building models. It creates smart digital 3D buildings to help the architectural, engineering, and construction sector visualize and communicate. The model integrates with 3D geographic information system platforms such as Autodesk and ESRI and can stream 3D urban buildings data to Cesium, Open Architecture Virtual 3D Globe, etc. It provides data for urban energy, sustainability, and design planning and works in conjunction with many smart city SaaS platforms such as CityZ. Kinetic roads. Italian startup Underground Power is exploring the potential of kinetic energy in roadways. It has developed a technology called Libra, a tire-like rubber paving that converts the kinetic energy produced by moving vehicles into electrical energy. Developed in cooperation with the Polytechnic University of Milan, Libra operates on the principles that a braking car dissipates kinetic energy. The cutting-edge technology is able to collect and convert this energy into electricity before passing it on to the electricity grid. In addition to improving road safety, the device upgrades and promotes sustainability of road traffic. Thank you for giving me the opportunity to present my presentation.